Hello, today I will solve IMC 2023 Problem 8. IMC is the International Mathematical Competition for university students. I have got 6 points out of 10 on this problem because I've got some minor mistakes in the Olympiad, and that's why I have lost gold medal and I got only silver here. In this problem we are given a tree. Tree is a graph which is connected, and there we don't have any cycles. And by DUV, we have denoted the minimal distance from U to V. Let WT be the sum of the distances from U and V. The U and V are any two vertices from a vertex set of T, and H of T defines the reciprocals of this sum. 1 over duv for every u and v. The u is not equal to v. And our aim was to prove that wt times h of t, this is more or equal to n minus 1 cubed times n plus 2 over 4. When I first saw this problem, the first idea that occurred in my brain is that I need to take the construction. I need to get the construction somehow. And the construction is very simple. We need to take this configuration is called star or sun. You can call anything you want. You need to choose one point as the center and connect all other vertices to this one. Let's enumerate all of them. 1, 2, all the way up to n minus 1. And nth one is itself C. This is the nth. And if we look at this configuration, we will see that this equality case attained only in this configuration. And we will see why this is correct. At first, notice in how many pairs of u and v maybe duv may be equal to 1. This means that these two vertices are neighbors to each other. And how many edges do we have? In that tree, if we have n vertices, then we will have exactly n minus 1 edges. So total number of pairs via duv equals 1 is n minus 1. And how many ways can we choose two different vertices? Clearly this is n choose 2, and this equals n times n minus 1 over 2. And now, how can we compute the number of pairs such that dvu is more than 1? To compute this sum, we need to subtract n times n minus 1 minus n minus 1, because this is the number of pairs via duv equals 1. And we get n minus 2 times n minus 1 over 2. And clearly this is also integer, because we have product of two consecutive integers. And now look at what may be the minimal sum of duv. Therefore, duv is more than 1. Clearly this is more than equal 2 times n minus 2 times n minus 1 over 2, because the distance may be more or equal to 2. duv in this case is always more or equal to 2. And what can be said in our case? Like, we can group the number of pairs u and v. The duv is more than 1 or greater or equal to 2, and like C and B, the distance between C and B equals 1. C and B equals 1. Then in this case, what can we say about the sum of the duv for every u and v? This is vertex set of T. The u does not equal to v. Clearly this number is more or equal to n minus 2 times n minus 1 plus n minus 1, because this is the minimal sum for the number of pairs. Their distance between them is at least 2, and this is the sum of the distances of the neighbor vertices, and clearly this is equal to n minus 1 square. And what can be said about the other features? Like, in this case, we need to compute what can we say about the 1 over d times uv. In this case, we need to use, if we are given some number of integers like a plus b plus and so on, like an, then we can write a2, a3 here, and a1 here, and 1 over a2, 1 over a2, 1 over a3, and so on. What must be the condition for this number to attain its minimum? Let's assume that a is more or equal to a2, more or equal to a3, and so on. And if we decrease the maximum element, if we assume that a1 is more than a2, then if we take a1 minus 1 and a2 plus 1, nothing will be changed for the left-hand side, left product, this one. But what can we see about the right-hand side? 1 over a1 minus 1 plus 1 over a2 plus 1. If we somehow prove that this number is less or equal to 1 over a plus 1 over 2, then we will finish the problem. Now take their product. So this would be equal a1 minus 1 times a2 plus 1 must be more or equal to a1 times a2. And clearly this is correct, because a1 and a2 are, if we expand this one, we get a1 times a2 minus a1 plus a1 minus a2, then minus 1. This must be more or equal to a1 times a2. And clearly this is correct if we assume that a1 was more than a2. And in such operations, we will get the minimum. So, and now we will see that this function will attain its minimum, then all of these numbers will be same. Like a1 must be equal to a2, must be equal to a3, and so on until a1. There may be some difficulty to find the exact equality, because some of them may be odd and some of them may be even. But in this case, their difference must be at most 1. Otherwise, we can do these operations and the maximum element will decrease 1 and minimum element will increase by 1. So in this case, this new number is less than the previous one. So right hand side, this right product will be minimized. Then all of them are equal to each other. And so we can see that the minimum is attained when all of these numbers are equal to each other. And if we know that we are given a number of pairs, their UV was greater or equal to 2, then their sum was assigned as S. Number of pairs equals n minus 2 times n minus 1 over 2. And this minimum, so AI, or this distance, must be equal, the UV must be equal to S over n minus 2 times n minus 1 over 2. Clearly this equals 2 times S over n minus 2 times n minus 1. If you want to find the minimum of reciprocals, we need to take each of them equal to this number. And what do we know about S is that S is more or equal, greater or equal to n minus 2 times n minus 1. And in this case, we can see that sum of the reciprocals, no 1 over duv, this would be greater or equal to n minus 2 times n minus 1 over 2, this is total number, times n minus 2 times n minus 1 over 2 times s, because this is reciprocal of 1 over duv, and this is total number. So this equals n minus 2 times n minus 1 square over 4 times s. And now what can we see in our problem? What was w of t? This was the sum of the distances, so this would be s plus n minus 1, because s was only the sum of the distances. This distance was greater or equal to 2. And what can we say about the h of t? H of t must be greater or equal to n minus 2 times n minus 1 square over 4 times s, then plus n minus 1. Now we need to take this product. And what can we say about this product? Wt times h of t. This would be greater or equal to s plus n minus 1 times n minus 2 times n minus 1 square over 4 times s. This over 4 times s plus n minus 1. And what can we see from here is that this function is more or equal to the, then we write instead of s n minus 2 times n minus 1, this number. We can see that this function is increasing for s. As s increases, this product will also increase. So minimum is attained and s equals to n minus 2 times n minus 1. If you got any questions about this one, you can write in the comments and I will try to explain this more clearly. Or we can use some differentiation also, or some properties of the quadratic equation to show that n minus 2 times n minus 1 is the case, then s attains its minimum. And because we know that s was greater or equal to n minus 2 times n minus 1, we can insert this number. And we get that this sum equals, the first one would be n minus 1 square. And what can we say about the second sum? This would be n minus 2 times n minus 1 over 4 plus n minus 1. And clearly this equals to the n minus 1 square times, if we add these two numbers, we get n minus 1 times n plus 2 over 4. And this is what we wanted to show, that this equals n minus 1 cubed times n plus 2 over 4. And this was our initial inequality, and we have shown that Wt times h of t is greater or equal to n minus 1 cubed times n plus 2 over 4. This was a very difficult problem to write without any mistakes for me. If you got any remarks, please write in the comments, and if you got any questions, also don't bother to write them in the comments. And these comments motivates me much more. And don't forget to like and subscribe my videos.